Phase Change Engineering Internship Day 2, Learning about Phase Change Materials. If you are watching the video instructions, they cover the entire lesson, so you will need to pause the video when necessary. Activity 1, Connecting to Futura Workspace. Open Futura Workspace and read the daily message from the project director. The new message, titled Day 2 Phase Change Materials, should be at the top of the inbox. Ensure you are clear on your tasks for the day. Completing the Modeling Thermal Energy Transfer sheet, reading and annotating Chapter 3, Temperature Plateau, after hours, rereading and revising annotations for Chapter 2, Phase Change Materials, and Chapter 3, Temperature Plateau. Teacher, introducing the daily message notes. The daily message tells the focus for each day during your internship. Each message will include some key ideas and list deliverables or tasks you need to do. As interns at Futura, each day you will begin by reading the daily message from your project director, Anton Green. You can confer with your colleagues and look at the glossary in the dossier if you need more support with engineering and project terms in the daily messages. Researching and collaborating are important practices for engineers. You'll need to take notes in order to keep track of important information. In Futura Workspace, select New Note to create a blank note. When you have a message open, selecting New Note pins the message open and moves it to the left panel, giving you a blank note on the right. Students, create a new note in Futura Workspace. Let's make an example on the board of how to record daily message notes. Give your note the title, Daily Message Notes. Record today's date and the subject of the message. Writing the date and message subject will help you separate the notes you make for this message from the ones you will make in the future. You'll also want to document important information like any deliverables. What important information should we record from today's daily message? You might say, Modeling Thermal Energy Transfer sheet, annotations for Chapter 3 of the dossier, after hours work, reread and revise annotations in Chapters 2 and 3 of the dossier. Students, revisit today's daily message and create your own daily message notes. For each daily message, you will return to your daily message notes to add new information. Teacher, Modeling Thermal Energy Transfer. As you read in the RFP, the incubator should work without electricity and the heating materials should be reusable. These are examples of constraints. Futura's chemical engineering team has already made some decisions about the design problem while they were getting things ready for you to work on. They found that the engineering problem posed by the Global Health Organization had certain constraints or limitations on the design solutions. These constraints influence the basic design that Futura engineers came up with. Constraint, a limit or restriction. At Futura, we must keep our creative ideas within our client's constraints. Based on the constraints for the project, Futura has decided to use phase change materials, PCMs, in their portable incubator design. Remember, you read about phase change materials in the previous workday, and Anton Green informed you in the daily message that you would be exploring PCMs in more detail today. Phase change material, PCM, a substance that stores, during heating, and releases, during cooling, large amounts of energy during phase changes. Futura sent some hand warmers for us to use as model PCMs. Each hand warmer contains sodium acetate and a metal disc. Chemical warning. Hand warmers contain sodium acetate, which is the sodium salt product of a chemical reaction between sodium bicarbonate and acetic acid. You will only come into contact with this chemical if the hand warmer breaks open. The chemical is non-hazardous and non-toxic, but you should be advised to thoroughly wash your hands and not ingest the chemical if it leaks out of the plastic pouch. You will work in groups to use these model PCMs to observe how thermal energy is transferred when a substance changes from liquid to solid and back again. Our models have some limitations. The hand warmers change between liquid and solid phases, but do not undergo a true phase change. However, in many ways they function similarly to the PCMs in Baby Warmer. Note, for more information on how the hand warmers function and differ from the PCMs, we can look in the teacher support materials. Safety guidelines for science investigations. 1. Follow instructions. 2. Don't taste things. 3. Smell substances like a chemist. 4. Protect your eyes. 5. Protect your hands. 6. Keep your hands away from your face. 7. Tell your teacher if you have allergies. 8. Be calm and careful. 9. Report all spills, accidents, and injuries to your teacher. 10. Avoid anything that could cause a burn. 11. Wash your hands after class. These guidelines are also in the digital resources as well as in your Futura Workspace inbox if you would like to refer to them later. You'll use these sheets to record your observations of the model PCMs. Before you activate the hand warmer, you'll record your observations in the table on the left. Handle the warmer carefully so you don't activate it too early. Next, you'll prepare a timer so you can measure how long it takes for the hand warmer to change from liquid to solid. You'll start timing when you activate the hand warmer. To activate the hand warmer, you'll gently bend, do not break, the metal disc inside. After activating the hand warmer, you'll put it down and leave it alone. Once the warmer has finished changing phase, you'll record your new observations in the table on the right. You'll also record how long the change took. Finally, you will decide whether thermal energy was transferred into or out of the hand warmer. Remember to record the evidence that supports your conclusion. Modeling thermal energy transfer. Make before observations. Circle the hand warmer starting phase and note how the hand warmer looks and feels. Measure phase change. Prepare a timer. Gently bend, do not break the metal disc in the hand warmer and put the hand warmer down. Time how long it takes for the hand warmer to finish changing phases. Make after observations. Circle the hand warmer's ending phase and note any changes in how the hand warmer looks and feels. Students, you'll work in groups of 4. Receive 1 hand warmer and 1 timer for the group and begin working. Do not touch the hand warmers until directed. Record observations before bending the disc and then continue following the procedure to complete the activity and fill out the conclusion section. While you are working, your teacher will prepare the boiling water so they can reheat the hand warmers at the end of this activity. Let's discuss your results and how they can help you think about your incubator design. Was thermal energy being transferred into or out of the hand warmer? You might respond, it was being transferred out of the hand warmer to the air or our hands. How do you know? We could feel it getting hot. Even though the hand warmers function a little differently than the PCMs in the incubator, the way they transfer thermal energy when they change phase is similar. How are your observations of this useful for the incubator design? We could say we're going to put PCM packets into the incubator to keep the baby warm. So now we know that when a PCM changes from liquid to solid, it gives off thermal energy. This is what will keep the baby warm in the incubator. Now I'll add thermal energy to the hand warmers. What do you think will happen to the hand warmers while they're in the boiling water? Respond to questions 1 and 2 on the second sheet. Activity 2, reading about temperature plateau. Today, you will continue your background research by reading and annotating Chapter 3, Temperature Plateau. Students, open the dossier. You can select the link in the daily message and use the table of contents to navigate to Chapter 3, Temperature Plateau. Last time, you read about how phase change materials, PCMs, store and release energy, large amounts, during phase changes. Today's reading is related to the cross-cutting concept of energy and matter. The processes that occur within a system are limited by the supply of energy, the ability to make things move or change, and matter, anything that has mass and takes up space. This cross-cutting concept is useful in other science and engineering topics. For example, your body cannot function properly without an input of matter, or food, and energy by the chemicals broken by the chemical breakdown of the food. Today, as you read more about the temperature plateau and how PCMs work, you'll be thinking a lot about energy and matter and how they interact to make the portable incubator work. In this design challenge, Futura's PCMs are special because they can easily transfer energy from the boiling water to the baby to keep it warm. Understanding how energy flows through the baby warmer system will help you create better incubator designs. In addition to recording your own questions and connections as you read, you can make annotations to help you answer these focus questions. What happens to energy and temperature at various parts of a phase change graph? And what is the temperature plateau? Asking questions and making connections are important parts of reading like an engineer. Also, remember to carefully review the diagrams and captions. You can use the glossary or use the reveal feature if you need more support within engineering and project terms. Read Chapter 3, Temperature Plateau. Make annotations about the relationship between energy and temperature. Discussing annotations. After reading, discuss the following questions with your partner. What questions did you write down? What connections did you make? What words are you unsure about? What annotations did you make to help you answer the focus questions? What happens to energy and temperature at various parts of a phase change graph? What is the temperature plateau? What annotations did you make to help answer our focus questions? Some ideas might be, thermal energy is transferred in during phase change from solid to liquid. Thermal energy is transferred out during phase change from liquid to solid. Temperature plateau is a time when the temperature and kinetic energy don't change even though thermal energy is being added or removed. It is when the actual phase change is happening. Temperature plateau, a period in which there is no change in the kinetic energy or temperature of a substance as it undergoes a phase change, even though energy is being added or removed. Students, be sure to answer the self-assessment question on the activity and then select Hand In. Earlier, I placed the hand warmers in boiling water to reheat. Then I took them out again. Let's observe the hand warmers now. Let's take a look at the reheated hand warmers. If the hand warmers that are cool enough to handle, I'll pass them around so you can observe the phase they are in now. This is the same method for charging PCMs that you will use in your incubator during designs for Futura. Record your observations of the hand warmers by answering questions 3 through 5. Let's discuss what happened when I reheated the hand warmers. What phase was the hand warmer in before boiling? A solid. What phase is the hand warmer in now after boiling? A liquid. Was thermal energy transferred into or out of the hand warmer while it was boiling? It was transferred into the hand warmer. How do you know this? We put the hand warmer into boiling water and the energy is transferred from hotter things to cooler things, so the hand warmer must have gained energy. Some interns may say that they know this because the inside of the hand warmer melted and things melt when they gain energy. One of the limitations of our hand warmer model is that there is no temperature plateau as it changes between a solid and a liquid. Let's discuss a temperature plateau graph for a true PCM. In the hand warmer model, there is no temperature plateau during the changes between solid and liquid because it is not a true phase change. If the hand warmers were true PCMs, they would have a graph like the one you're about to see. This sample graph is like the one in the PCMs from the baby warmer. The graph shows what happens when a PCM changes from liquid to solid during cooling, and then from solid to liquid during heating. You will be working with these types of graphs a lot as you finish your research and you start your designs. Notice the x-axis showing time across the bottom and the y-axis showing temperature along the side. The flat parts of the graph are temperature plateaus that occur during both of the phase changes. Why do you think the melting process takes less time than the freezing process? We are actively heating the PCM in boiling water, so the rate of thermal energy transfer during melting is faster than during freezing. During cooling, thermal energy is transferred out at a slower rate than the thermal energy being transferred in. The difference in the time for the phase change is because, due to the very high temperature of the boiling water, thermal energy is transferred to the PCM during heating much faster than it is transferred out during cooling at room temperature. During freezing, stored potential energy from the freezing substance is transferred and converted to thermal energy in the surroundings. The temperature and kinetic energy of the substance remain constant during the freezing process. Remember that you felt the thermal energy being transferred out of the hand warmer as it was changing from liquid to solid. During melting, thermal energy from surroundings is transferred in and converted to potential energy that is stored in the melting substance. The temperature and kinetic energy of the substance remain constant during the melting process. Remember that this happened as I heated the hand warmer in boiling water. Activity 3, After Hours Work. For this task, you will reread chapters 2 and 3 and add to or revise your annotations. You'll reread with a new focus, your portable incubator design. Remember, scientists and engineers often revisit texts when they are conducting research. Rereading this chapter will help you prepare as you further research temperature plateaus during the next workday. You do not need to submit your annotation revisions. Students complete the task after hours. End of lesson.